Bismillahirrahmanirrahim. My name is Muhammad on Munir, roll number 21T05. Today I am able to discuss lab 6 of digital signal processing. Our instructor is Dr. Muhammad Jamil. First of all, I have done all the tasks on MATLAB and made a PDF for my convenience. So I am able to perform all the tasks. So first of all I show all these tasks and then show its input and output. So moving toward lab objective of this lab, that is representation of discrete time digital signal into frequency domain via FFT, resolution of spectrum, computation of magnitude, phase and power spectrum, spectral leaking and avoiding spectral leaking. So moving to a task 1, that is write a MATLAB program to validate the above given decimation program. First divide the given signal into even and odd samples, calculate DFT for even and odd samples separately, and then merge both of them using formula. So then moving toward input of this function, that is first of all we define a given signal, that is array 1 2 3 4 5 6 7 8. Then we define a decimation factor, that is m is equal to 2. Then divide this signal into even and odd samples, and then divide DFT for even and odd samples separately, that is n is equal to length of x of e, n of odd, that is length of xo, g is equal to f of t of xe, and g o f of t over xo. Then merge both of them using a formula, that is n is basically length of x is equal to zeros from 1 to n, using for loop from k is equal to 1 to n, using basically formula, and then finally display the result, that display command original signal, that display decimated signal, then display reconstructed signal, then using inverse of f of t. So we get an output, that is original signal, that is 1 2 3 4 5 6 7 8. Then that decimated signal 1357, then get reconstructed signal. That is task 1. So moving toward task 2, which states that check the above program for the given signal given below, that is x1 that is 13, x2 that is 1030, x3 24, x4 204, x5, x6, x7 and x8. Then demand that observe and find any symmetry in frequency representation. Also match the calculated DFT with standard MATLAB programs. So moving toward input the source code of task 2, that is we define a signal, that is 2424. Then define decimation factor, that is m is equal to 2. Then divide that signal into even and odd samples, x is equal to x1 and x naught is equal to x1. Define a limit from 1 to 2 and 2 to 2, and then using n, then calculate DFT for even and odd samples separately. So then merge both of signals using formula, using a for loop, and by using this formula we get an end of for loop. Then display the result, that is original signal, display x1, display decimated signal using inverse of FFT, that compare DFT with standard MATLAB function, that is display DFT of x1, display FFT, display DFT of decimated x1, then display x. As a result we get an output, that is original signal 2424, decimated signal, that is 3333, DFT of x1 and DFT of decimated x1. That is number task 2. Now moving toward task 3, which states that check the program in task 1 for the signal given below and compare it with standard function, and given x and y. So moving toward input, that is given signal, that is x and y. We define decimation factor, then divide that signal into odd and even samples, then calculate DFT for even and odd samples separately. For that we that NE, NO, GE, GO, NE, NO, HG and H0. Then define length, then define zeros. Starting for loop using formula, uh, and then display the original and decimated signal, that is the display of original signal, display of decimated signal, and display of original y, and display of decimated signal x using FFT. Then compare DFT with standard MATLAB function, then display DFT of x, display FFT of x, display DFT of decimated x, then display of DFT of y, display of the FFT of y, display DFT of decimated y, and display y. As a result, we get an output, that is original signal, decimated signal x, then original signal y, decimated signal y, and then DFT of y. So moving to our task 4, which states that we can further subdivide the above decimations up to 2 samples and calculate the DFT of 2 samples, that then 2 sample DFT added to form 4 sample DFT, and 2 4 sample DFT form 8 sample DFT, and so on. This 2-point decimation is called radish 2 fast forward transform algorithm. Write a program by DFT that transform a given signal into frequency representation using Redis 2 FFT algorithm. So moving toward input of task 4, that is first of all we define a function, that is my FFT, then define length, then if n is equal to 1, then x is equal to x, then return, then define the signal into even and odd samples, and then merge the DFTs using a for loop, and that all these functions are belong to for loop using end, and then define input signal, calculate the frequency representation using above defined my FFT function, then compare with standard MATLAB function, that is FFT, then display the results. As a result, we get an output, that is my FFT, that we define in above section, and then MATLAB standard function FFT, we get an output like this. Now moving toward our last task of this lab, that is calculate the fast forward transform using on function, that is we define in task 4, and compare it with standard function by calculating DFT. So we are given 4 standards, wx, y and z. So moving towards source code of this task 5, that is first of all we define the samples wx, y, z, then calculate the FFT using custom functions, and then calculate the FFT using the standard function, then compare the results with standard and custom functions. As a result, we get an output of results of my FT compared to FFT, then signal y and signal z, both in custom function as well as in standard form. So these all tasks are from lab number 6. Thank you so much. Allah Hafiz.